Hey guys, and welcome to Classification with Neural Networks. So in this section we're going to take a look at what is a neural network and when do we choose one, and we'll also look at implementing one with dlib, and then we'll also be discussing neural networks. So when is a neural network appropriate? So this is the first video, and we're going to look at this video, obviously when is a neural network appropriate and what is one and when to choose one. So what is a neural network? So they're supervised machine learning algorithms that can perform a variety of tasks, but primarily they do classification, and they're modeled in a similar way to how the brain works. So what you do is you set up millions of neurons in the network, and then they all connect in various ways to each other in a similar way to how the brain works. Now the advantage of this is there's so many possible combinations of weights and connections that you can basically train anything to match your data. But the problem is you've got to have enough of your data because there's so many combinations. Otherwise, you can end up with several different duplicate combinations, not duplicate combinations, but combinations that achieve the same class or classification for if you're just training with a single image. So you need billions to kind of spread it out. So yeah. What you do is you have these neurons, and then they connect in various ways to different values. And then go down, you kind of reduce in certain ways, or you can expand, and then you get an output. At the end of each neuron, generally you have an activation function. And they're just small functions that pass in a single value, because it's just a single scalar that's passed into a neuron, and then it just goes through this activation function before it is outputted to the next neuron. And they're very important as they help to model non-linearities of the function. There are several around, but most common they use ReLU or sigmoid. So yeah, you can see sigmoid is kind of referred to as the soft step, and ReLU is just like a ramp that can't be negative. So yeah, that's activation functions. So how do you train a neural network? So basically you pass in lots of images, and then you have some initial weights. So it's just basically subgradient descent. And you have some initial weights, you compute the output, and then you compare it with the ground truth, so you get an error value. And then what you do is something called back propagation. So you propagate the error backwards, and you update the weights accordingly. Now it's a very efficient way to train a neural network. Works very well. It's used almost unanimously all over the world. So it's just subgradient descent, really, just a little more complex. We don't really need to go into the details of it. No one ever implements propagation themselves. They often use libraries, so it's very easy. But yeah, so neural networks, as you can tell, they're only really appropriate when you've got thousands and thousands of data entries that have labeled ground truths. So you can't do this for unsupervised machine learning, and you can't do this when you've got a small data set. You need to have thousands and thousands of labeled data.